All right, so if you were asked to solve a system of equations like this, you would probably not want to do substitution, because if you try to get an x or y alone, you'd be dividing by 5 or 7. This one wouldn't be too bad if you divide everything by 2 and got the y alone, but it would be a couple of steps to do that. And it's fairly easy to do elimination, except that we need to make a couple of changes. We need to multiply both equations by something. So if I look at my x's, I have a 7 and a 4, so I could get them both to 28. I could get one to 28 and one to a negative 28. If I look at my y's, I could get them both to 10. And one actually would be positive 10 and one would be negative 10. Simply because those numbers are smaller, I'm going to choose to do that. So I'm going to multiply my top equation by 2 and my bottom equation by negative 5. One of them needs to be multiplied by a negative number. It does not matter which one. All right, so if I multiply this by 2, I get 14x plus 10y is equal to negative 6. When I multiply this by negative 5, I get negative 20x minus 10y is equal to positive 30. Now I'm ready to combine, and one of my letters should be eliminated. Negative 20 plus 14 is negative 6, so that gives me negative 6x. And 30 minus 6 is 24. Divide both by negative 6, and you get x equals negative 4. Once you have your first letter, so in this case we have x, we're going to plug that back into one of the equations. So I would do 4 times negative 4 plus 2y equals negative 6. So that is a negative 16. So I'm going to add 16 to both sides. So that's going to give me 2y is equal to positive 10. 16 minus 6 is 10. Divide both sides by 2, and you get y equals 5. Therefore, my ordered pair is negative 4, 5. So if you need to multiply both equations by two numbers, that's fine. You can do that.